Dear students, under the topic polar coordinates, we are learning about the angle of intersection of two curves. Here we have problem 5. The question is, show that the rectangular hyperbola r square sine 2 theta equal to a square and r square cos 2 theta is equal to b square intersect at right angles. We know that the angle of intersection of two curves is given by xi, which is equal to phi 1 minus phi 2, where phi 1 is the angle between the tangent vector, radius vector and the tangent of a curve, and phi 2 is the angle between the radius vector and the tangent of the second curve. Now using this, we will be finding the angle xi, which is the angle between the two curves. So for this, first we shall consider the first curve as equation 1, and let us rewrite this as, that is, the first curve is r square sine 2 theta is equal to a square. Now let us rewrite this curve as r square is equal to a square divided by, so sine 2 theta, when it goes to the right, it goes to the denominator. So we have sine 2 theta in the denominator, and this is equal to a square cosecant 2 theta, because we know that 1 by sine theta is equal to cosecant theta. So therefore 1 by sine 2 theta will become cosecant 2 theta. So therefore we have rewritten the given first curve as r square equal to a square cosecant 2 theta, and let us mark this as equation 1. Now we shall differentiate equation 1 with respect to theta. What we get is the differentiation of r square is 2r multiplied with the differentiation of r is dr by d theta, and that is equal to a square is a constant in multiplication, so it will come as it is. So a square, the differentiation of cosecant theta is minus cosecant, because we have 2 theta, we should write cosecant 2 theta cot 2 theta. This is by the formula for the differentiation of cosecant theta, which is minus cosecant theta cot theta. Now because we have cosecant 2 theta here, its differentiation will be minus cosecant 2 theta cot theta multiplied with the differentiation of 2 theta. The differentiation for theta with respect to theta is 1. So this constant will be multiplied. So 2 into 1, so 2. So that is how we get it. Now if you see, we can cancel out the 2 on both the sides. So this 2 and this 2 gets cancelled, and we get dr by d theta to be equal to, taking this r to the right, it goes to the denominator. So this will be equal to, we have a minus sign, so minus a square cosecant 2 theta cot 2 theta the whole divided by, this r when goes to the right, it goes to the denominator. So we have this. Now we shall take this and substitute in tan phi. So we know that the angle between the tangent and the radius vector phi 1 is calculated by tan phi 1 is equal to r into dr by d theta. D theta by dr. So this is the formula for tan phi. So this is equal to r multiplied with, what is d theta by dr? It is the reciprocal of dr by d theta. So the reciprocal of this. So this r in the denominator will go to the numerator, divided by minus a square cosecant 2 theta cot 2 theta. So now we have r multiplied with r, which is r square. And so this will be equal to, we will write this minus, and then r square divided by a square cosecant 2 theta cot 2 theta. But what is r square? From equation 1, r square is equal to a square cosecant 2 theta. So we can substitute that over here. So that will be equal to minus a square cosecant 2 theta divided by a square cosecant 2 theta cot 2 theta. So if you see here, this a square and a square gets cancelled. Cosecant 2 theta and cosecant 2 theta gets cancelled, and this will be equal to minus 1 by cot 2 theta. But what is 1 by cot? It is tan. So therefore tan phi 1. So this tan phi 1 is equal to this 1 by cot 2 theta can be written as tan 2 theta. So minus, we have this minus over here, minus tan 2 theta. But what is minus tan 2 theta? This can be written as tan of minus 2 theta, because we know that tan of minus theta is equal to minus tan theta. Using that identity, minus tan 2 theta can be written as tan of minus 2 theta. So while comparing the left hand side and the right hand side, we get the angle phi 1 to be equal to minus 2 theta. So therefore, we have obtained phi 1 to be equal to minus 2 theta. In a similar way, let us obtain the angle phi 2. In order to obtain the angle phi 2, we should consider the second curve that is given. What is the second curve? It is r square cos 2 theta equal to b square. So let us take this and write first. So we have taken and written that. So r square cos 2 theta equal to b square. Let us rewrite this as we did the previous curve. So we can write this as r square equal to b square divided by cos 2 theta. But what is 1 by cos? It is secant. So this is equal to b square secant 2 theta. So therefore we get r square equal to b square secant 2 theta. So we have rewritten the second curve, and let us mark this as equation 2. Now let us differentiate this equation 2 with respect to theta. So when we differentiate equation 2 with respect to theta, we get the differentiation of r square is 2r multiplied with the differentiation of r, which is dr by d theta, and that is equal to b square is a constant, and the differentiation of secant theta is secant, because we have 2 theta, it is secant 2 theta tan 2 theta. We know that the differentiation of secant theta is secant theta tan theta. Using that formula, the differentiation of secant 2 theta will be secant 2 theta multiplied with tan 2 theta, and this has to be multiplied with the differentiation of 2 theta. The differentiation of theta is 1 and 2 is a constant which has to be multiplied. And if you see, this 2 on the right and 2 on the left gets cancelled, and further we get dr by d theta to be equal to, we have b square secant 2 theta tan 2 theta divided by, so when this r comes to the right, it goes to the denominator. So we have this. Now let us write tan phi 2, which is given by the formula r multiplied with d theta by dr, which is equal to r multiplied with, what is d theta by dr? It is the reciprocal of dr by d theta. So the reciprocal of this implies that the denominator becomes the numerator and the numerator becomes the denominator. So when we write here, this r comes in the numerator divided by b square secant 2 theta tan 2 theta. Now if you see, when you multiply r square and r square, you get, r multiplied with r, you get r square. So you get this as r square divided by b square secant 2 theta tan 2 theta. But from the curve 2, we know that r square, that is equation 2, we know that r square is equal to b square secant 2 theta, which can be substituted here. So this is equal to b square secant 2 theta divided by b square secant 2 theta tan 2 theta. Now if you see, we can cancel b square and secant 2 theta. And what is 1 by tan 2 theta? It is cot 2 theta. So therefore tan phi 2 will be equal to cot 2 theta. And this cot 2 theta can be written in the terms of tan by using the formula. We know that tan 90 minus theta is cot theta. And because we want cot 2 theta, we can write this as tan 90 minus 2 theta. Because 90 is equal to pi by 2, I am writing it as pi by 2 minus theta. Because we have 2 theta, I am writing it as 2 theta over here. So therefore comparing, that is tan phi 2 is equal to tan pi by 2 minus 2 theta. So when we compare this, we get phi 2 to be equal to pi by 2 minus 2 theta. Already we have obtained phi 1, which was equal to minus 2 theta. So the previous one we have obtained phi 1 to be equal to minus 2 theta and phi 2 to be this. We know that the angle xi is equal to phi 1 minus phi 2, or we can also write it as phi 2 minus phi 1, because anyway we will be taking only the positive value, the absolute value of this, though I am not mentioning it here. So we can write it as phi 2 minus phi 1. Because we observe that this angle is greater than this angle. So in order to avoid the negative angles, we are subtracting phi 1 from phi 2. So remember, angle xi is equal to phi 2 minus phi 1, or it can be phi 1 minus phi 2, because anyway we will be taking only the absolute value, that is the positive value. So I am subtracting in this manner. So that phi 2, when I substitute, we get pi by 2 minus 2 theta. And then minus phi 1. So minus, here we have phi 1 to be minus 2 theta. So minus of minus 2 theta, which will become plus. So that is equal to pi by 2 minus 2 theta, and minus of minus becomes plus 2 theta. And we see that negative 2 theta and 2 theta gets cancelled, and we find the angle to be pi by 2. So therefore the angle of intersection between the two given curves is equal to 1 pi by 2. That is, they cut each other at 90 degrees. So they cut each other orthogonally. Orthogonally means they cut at the angle 90 degrees. Okay, so therefore we have got the angle of intersection between the two given curves as pi by 2. So this is the answer. Hope you have understood this problem. Thank you.